This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio brings you relevant and detailed discussions and interviews on software engineering topics every 2 weeks. Thanks to our audience and the partners listed on our website for supporting the podcast. So, welcome listeners to a new episode of Software Engineering Radio. This episode is once again a programming language episode. It's one of my favorite kind of episodes because, learning programming language concepts, at least the concepts if you don't learn the language, is very useful. And this time we're covering a very new language called Ioke. And at the other end of the Skype connection is Ola Bini. Hi.
Hello there.
And he's obviously the guy who created Ioke, so he should be able to talk about it. So, Ola, why don't you introduce yourself to our listeners before we start talking about Ioke?
Okay, so very quickly, my name is Ola Bini. I live in Sweden. I'm a Swede. I work with ThoughtWorks globally, and I've done that for 2.5 years, doing all kinds of different things, including consulting. My main time is actually spent doing JRuby core development. So that's basically my background, JRuby.
I knew that you had this background, but I wasn't aware that you're still doing it.
Oh, yes, I am.
Okay. But you don't talk much about that publicly. You basically talk about Ioke.
Yeah, I know. But I'm slugging away doing stuff. This summer, I wrote a new YAML engine, a few things like that. So it happens. And I also do it for as a consulting part for ThoughtWorks.
Okay. So then I would assume that Ioke is somehow inspired by Ruby, but we'll talk about that later. So what is Ioke? Can you give a brief overview in like 5 sentences or something?
So first, it's actually Ioke.
Okay.
No worries. So Ioke is an experiment. That's really the first point. It's an experiment in expressiveness. It's secondly a dynamic, strongly typed, prototype-based, object-oriented language. That's basically the core of it, and it's got the same kind of macro facilities as Lisp, for example, while still having enough syntax to feel like Ruby. Mm-hmm. So those are kind of the main points of the language.
Okay, and we'll talk about many of these things in detail, of course. But so you already said it's an experiment. So my next question would be, why yet another language? And I guess you kind of answered it already. You wanted to show something with that language as opposed to necessarily, having another, let's say, production language out there. So what's the goal of the experiment?
Yeah, so as I mentioned, expressiveness. It's kind of interesting. I'm a language geek, so I know a lot of languages. I think it's really, really funny and relaxing to read language specs and so on. And one of my absolute favorite languages when it comes to expressiveness is Common Lisp. Mm-hmm. I'm a Lisp head in general, but Common Lisp is definitely the pinnacle for me of both being a production language and being something that is extremely expressive and allowing you to basically just form the language that you want to use to solve the problem and then solve the problem in it. Mm-hmm. But when you start looking at the spec, you'll start reading a few magic sentences that crop up on almost every page in the Common Lisp spec. And that's basically that the committee that designed Common Lisp made this and this decision to make it easy for implementers to implement it efficiently. Mm-hmm. So what I started thinking about is, so if the most expressive language I know was compromised to make it performant, what does that mean? Does it mean that if I don't care about performance, maybe I'll get a language that is even more expressive? Mm-hmm. So that's kind of the goal. I wanted to see if Lisp really is the most expressive you can get, or if you can get any higher on the scale of expressiveness.
How would you define or illustrate expressiveness?
Yeah, and that's a very good point, because that turns out to be the problem. I do have a paper on my desktop that I haven't read yet about an objective measure of expressiveness, but I haven't really found anyone that can actually define expressiveness. I've tried several different things. Sometimes people say try to use power as a synonym, or they use abstraction capabilities, stuff like that. But it turns out they have the same problem when it comes to defining them. So at the end of the day, for me, expressiveness is a very subjective thing. Mm-hmm. it basically means how large is or how small is the difference, the distance from how I think about a problem to how I express it in code.
Mm-hmm.
If I can think about a problem and just take that thinking and put that into code directly without any translation, then that means that language is very expressive. And the other way around, if I have to muck around trying to figure out how to organize it into a Java class hierarchy and fit in all the static keywords or whatever I need to do, then that's probably not as expressive.
Right. Okay. And we'll probably see through the episode how you approach the problem or the challenge of making things more expressive, and then the listeners can judge for themselves whether they think that's more expressive than, say, Java.
Hopefully.
I mean, the next thing I've written down here was the set of languages that inspired Ioke, and obviously, I guess it's probably Lisp, since you've already mentioned that. So, any other influences?
Well, IO is actually the language that is the closest kind of parent.
Mm-hmm.
That's where some of the semantics and some of the syntax came from. IO is a very small language too. It's actually a very nice language, but they didn't go far enough when it came to expressiveness. So I wanted to get further than that. Obviously, Common Lisp is definitely more from a philosophy standpoint, but also when it comes to macros and stuff like that, it's more like Common Lisp.
Mm-hmm.
Ruby has influenced a little bit when it comes to the syntax, not how the syntax works, but what the syntax actually looks like. But the most that Ruby inspired is the standard library,
mm-hmm.
or the core library. So the core library, you will recognize yourself if you come from a Ruby background.
Mm-hmm.
And self is actually also a quite common parent.
The prototype stuff.
Exactly.
Something that I was reminded, although right now I can't remember where and when this thing popped to my mind, was Smalltalk. I mean, obviously everything is objects and messages.
Yeah. Well, self is a Smalltalk.
Well, it's not necessarily, a dialect kind of.
Yeah. Itself is definitely considered part of the Smalltalk family.
Okay. Then I guess we're on the same page.
Yeah.
Okay. So I guess you already talked about the syntax being a bit different than Lisp. I mean, I always joke that Lisp has no syntax, and of course, if you can make your users write down abstract syntax trees, that's very convenient.
Yeah.
So how does Ioke, I probably pronounce it wrong again, syntax differ, and what role do messages play and that stuff?
Yeah, so it's interesting that you bring up the whole Lisp and syntax thing, because one of the things that I think the Lisp community got wrong is that syntax actually does matter, and saying that it doesn't matter doesn't really help most of the programmers. I think that you can make code that is more readable and easier to read and easier to maintain if you have a small amount of syntax to help you.
I agree.
But obviously, the main advantage of being in Lisp is the fact that if you don't have any syntax, it makes it very, very easy to do macros.
Sure.
You get the homoiconicity for free. So I didn't really want to get rid of that advantage. I thought it was really, really powerful, and I thought it was really necessary for Ioke to have the kind of macro facilities. So what I ended up doing is that so Ioke basically has two different layers of syntax. The first one that is actually the one that is parsed is now a truck passes by outside here. They're doing some construction work in my park.
Actually, I didn't hear it, so no problem.
Okay, good. Now, so the first stage is the parser. That parser is extremely simple. It really only does whatever is necessary, and it doesn't really distinguish between. It doesn't look at things like operator precedence. It doesn't really do anything of those fancy things. The only thing it does is to parse messages and arguments to messages. And the second stage is called operator shuffling. And the operator shuffling stuff, that is really where you have precedence between things, where things like assignment is actually rearranged into an assignment message and a few things like that.
So can you give an example of, for example, how the assignment looks in the parsed syntax and what it's shuffled to?
Well, I mean, so the first step So you have the first thing you have to realize if you're familiar with self or IO, for example, is that I don't use dots for method calls. Instead, I use spaces.
Okay.
So, say for example, I have an object called foo, and I want to set the x property on, or I want to set x on foo to the value 42. So in Ioke, I write foo space x space equals space 42. Right? And that's exactly how the parser will parse that. It will parse that into four messages, basically. The foo message, and then the bar message, and then the equals message, and then the 42 message. That's a different thing. The 42 thing, we're going to get back to literals later, I think, because they are kind of interesting too. But so that's what the AST will look like before operator shuffling. So you can also say that the operator shuffle, or the parsing step, the first parsing step, is just parsing a canonical syntax. And then the operator shuffling rearranges, or actually you can say the parser step parses to a raw syntax, to a raw AST, and the operator shuffling rearranges it to the canonical tree. So after the operator shuffling step, the actual new AST will say foo equals sign, and then the equals sign will have two arguments, where the first argument is x and the second argument is 42. So assignment is just a message send where you send in the name of the variable to set and the values to set it to.
Okay.
And the same kind of thing happens. So if you have a plus and multiplication, for example, operator shuffling will make sure that you get the right kind of
So in some sense, operators aren't anything special once you've done the operator shuffling. They are just messages.
They're not special before either, actually. The only thing that makes something an operator is if they are in the operator shuffling tables. And that's something that you can change at runtime if you want to.
Okay. Because I mean, what I meant by special was that they can be used in different places and in different ways, which is then resolved by operator shuffling.
Yeah, exactly.
Okay.
And so everything you can use as an operator is just a message, and you can write the canonical syntax yourself if you want to. So if you really want to send a message equal sign or something like that directly, you can write it that way instead, and it works out correctly too. That syntax is obviously more like Lisp.
Yeah.
Even though it's outside in, so the name is coming outside parentheses.
Okay. So in your example with foo x equals 42, you said that you have four messages, the foo also being a message. Now the question is, I mean, I can imagine that you sent the x message to the foo thingy, but the foo is the first message. Who do you send it to?
Oh, that's so everything in Ioke executes against the receiver. This is kind of the basic Smalltalk idea. Everything needs to have a receiver. And the implicit receiver in a specific context, I call that ground with lower g. So that's kind of the receiver. When you don't have an explicit receiver, it's going to be the ground. I didn't want to use context because context is one of those words in CES that is really, really overloaded.
Yeah.
So I use ground instead. And if you do this at the top level, the default ground is going to be ground with capital G. I know that's confusing, but it does make sense. The interesting thing about ground, and we haven't really talked about this yet, but as it turns out, ground is actually in the inheritance chain, which means that every object you create will have ground as one of the parents. So if you define something at the top level, that will actually be defined in the ground object, which means that it will be available to all objects that are part of the regular hierarchy, so to speak.
Okay. So in some sense, that's a fancy way of doing global variables.
Yeah, except that it isn't global, because you can actually do things that don't have access. Everything in Ioke is actually namespaced. So nil and true and false are also messages, and they also live on one of the ground objects. And you can create new objects that don't really take part of this inheritance chain. So everything is looked up through the inheritance, and you can tune that if you want to.
I understand why this is nice from a, let's say, making everything built from the same building blocks kind of thing. But what's the benefit in practice? I mean, the problem with global variables is that you can have side effects. You have effects on global state that is not explicitly, available through some kind of dependency analysis and whatever. What's the advantage of doing it through ground?
Actually, I mean, that feature of the whole thing, not having globals, wasn't something I designed in.
Okay.
It just turned out that way from some of the other design goals of the language, where simplicity of where the simplicity of the model was really the main design goal that made it happen. So why do I need to have two different naming scopes if I can get away with just having one, for example?
Mm-hmm. Okay.
So not having globals was actually just a side effect of that.
Mm-hmm. Okay. Good. So you already talked about inheritance and stuff, so I guess objects are an important building block of Ioke. You already said that this is a prototype-based language, so you don't have classes. So I guess most of our listeners, since we didn't have an episode on self yet, you might have to explain what it means to be a prototype-based language. Okay,
so the basic idea here is that you don't have most object-oriented languages, except for Common Lisp, which are Common Lisp has three different kinds of objects, but most object-oriented languages are falling into the whole class-based object-oriented paradigm, where you have classes that contains methods, and then you have the objects that are of the classes in some way. Now, in some languages, Smalltalk is a typical example. The classes in themselves are also objects, but they're still special objects since they can contain methods.
Yeah.
A prototype-based language just removes the whole idea of classes and says that everything can have objects. There is no distinction. There is only one kind of object, and that object can have slots or methods or whatever you want to call them. Now, there are a few different ways of doing that. There are two main paradigms of doing it. The first one is where you just, every time you create a new object, you take it from an existing object and then you copy everything inside of that object.
Mm-hmm.
This is the method that self uses. That's not the way Ioke works. And for example, JavaScript is another example of a language that doesn't do that. Instead, these languages keep a pointer to the object they were created from. And when you look up something, you start looking up in the object itself, and then if you can't find it, you look up in all the parents.
Right.
So in Ioke, an object is actually very, very simple. An object really has two things in it. It's got a set of cells, and those cells are more or less like slots or properties in other languages. They're binding between a name and a value, and they have a set of mimics. And the mimics are kind of the parents. I use the word mimics because one of the things that I've tried to do, since it's an experiment, I tried to see what happens if I change the names of the core concepts. I don't want people to have preconceived notions about what things mean just because I use the same name. So the cells and mixins or mimics are a typical example of this. Now, if you want to understand why I choose the word mimic, it's actually quite easy to understand. Say you have this object that we already have, and you want to create a new object based on that. What we really want is a new object that mimics the original object, that behaves just like it, except for a few cases where it doesn't. So mimic actually makes sense from that perspective.
Mm-hmm. So two things that I just noticed, or think I noticed. One is that in that model, delegation and inheritance are somehow kind of the same thing, right? Because, I mean...
No, not exactly. You can still do delegation by having cells inside of the object that you delegate stuff to.
Yeah, but I mean, looking something up in the parent is also a delegation to an object that has, that one of your mimic pointers point to.
Yeah, true, absolutely.
So it's a much more homogeneous approach to things.
Interestingly enough, I haven't thought about it that way, but that actually makes sense. And it turns out that the Ioke inheritance chains have a tendency to be a little bit larger than most class-based object-oriented languages inheritance chains.
What do you do in case of, quote, multiple inheritance if you have several mimics that happen to provide contents for the same cell? So in other words, you could, if object if an object doesn't have something in a cell, you delegate the lookup to the mimics and you find something in more than one mimic. What do you do? It's just basically first one wins? Or?
So Ioke's lookup procedure is actually quite flexible. It's also deterministic. It's basically depth first. No, actually, yeah, it's depth first, left to right. Okay. And since you can change the mimics at runtime, you can have 0 or more mimics. That means that you can do some pretty strange stuff. You can have recursive mimic chains, for example. Okay. You can have an object that mimics itself if you really want to.
And why is that? Well, that's more like a bug, right? I mean, that's
it's probably a bug in almost all cases, but in some cases, it's kind of useful to have objects that depend on each other.
Right.
I haven't seen a use case for that in reality, but I didn't really want to disallow it. So it's handled correctly. Basically, Ioke just uses the first one it can find.
Right, okay. And then there is another thing, which is that you can easily add behavior, since behavior is just cell contents, you can easily add behavior to only one object and not to classes. I know that the term class doesn't make sense, but in the old world or in the class-based languages world, you would be able to add stuff to only one object as opposed to the class.
Yes, true. And I mean, that's one of the things in Ruby you can do.
Yeah.
In Ruby, it's actually, it's actually faked because when you add a new method to a specific object, there is actually a new class springs into existence that you can't see that sits between the real class and the object. In Ioke, so I want to take a step back and just say quickly why I choose the whole prototype-based model, because it's also based on the core principles behind the language. Except for expressiveness, I tend to believe that simplicity is really, really important. And one of those things is basically if you have two kinds of objects, you need to handle them in the runtime. But if you so it makes sense to just have one kind of object because that makes the whole runtime model simpler. Simpler to understand. So that was kind of the main reason. It's just because of simplicity of the model.
I mean, this whole discussion about simplicity, I think, is extremely interesting because, I mean, if you look at Lisp, right? Mm-hmm. It's a very simple language. It only has basically one concept, which is lists, okay? And then there are macros and a couple of special forms, but okay.
Well, I would argue that Common Lisp is pretty complex.
No, I mean not the Common Lisp standard, but the original scheme-like Lisps, the thing that's like pure Lisp.
Of course, pure Lisp was actually dynamically scoped, which is not like at all.
My point is trying to get to something else, which is, on the other hand, other people say Java is very simple because it only has three concepts like classes, methods, and properties, and then a bunch of statements and expressions. So I think the question of what constitutes a simple language is not quite obvious, because if you say it has fewer concepts, so it's simple, so it's very powerful, doesn't mean that it's easy to use, because you have to now kind of assemble more higher level abstractions from those simple concepts. See what I'm getting at?
I do understand, even though I would never argue that Java is a simple language. The reason I say, for example, that Ioke is very simple is because I've just described the object model. The object model that everything in language uses is the whole idea of cells and mimics. That's the only thing that exists.
See, but if I take it to an extreme, I can give you a much more simple language.
Yeah.
Which is basically bits, right? You have only 0 and 1s. You can explain everything in terms of 0s and 1s. But
sure. But you have no semantics on the bits. If you actually want to have semantics on them, you'll have to assign. You'll have to say this bit pattern does this.
Okay.
So I would say the absolutely simplest model that you can say that is the simplest one that can describe everything is actually lambda calculus.
Mm-hmm, yeah.
Lambda calculus is basically the simplicity as its core, because you can represent all the other things. Ioke is not really exactly that simple. It's slightly more complex than the Lisp model, but it's not much more complex in terms of... most Lisps are defined in terms of special forms. I think that the standard Lisp 1.5 special forms need about 7 special forms to describe it.
Mm-hmm.
And Ioke is slightly more complicated. The reason Ioke is a little bit more complex is because of the object orientation, because you have to have a receiver for everything, which makes it's definitely an integral part of the language, and it's definitely part of what makes it powerful.
Yeah.
So you don't need an explicit module system or package system, because you already have everything namespaced.
Mm-hmm. So I guess one outcome of the experiment will be whether Lisp didn't catch on in mainstream because it's so simple in the terms you've just defined it, or because of the, lots of irritating silly parentheses. So you see, I mean, maybe Ioke is as simple, but it removes some of the awkwardness of how Lisp looks, and the experiment will be maybe whether then it can catch on and people consider this kind of simplicity as really simple.
Yeah. And I have no idea. It's going to be interesting to see what happens with that one. I mean, I'm going to be happy if in 5 years any other language have adopted some of the ideas from Ioke. Right. That's definitely going to be a success from my perspective. So,
okay, that was kind of a diversion. Let's go back to the objects thing. So, what do you do if you want to define something that plays the role of what classes play in class-based languages? So, how do you define something of which you can define instances or mimics? How do you go about that?
Well, I mean, so there is no real class-based thing, obviously, but I do have a convention that if you name something that starts with a capital letter, that will be considered as a kind, where a kind is kind of a way of talking about classes. So, for example, list with a capital L is actually the kind that all the other lists in the system are based on. Yeah. But that's just convention. It's something that the runtime system knows a little bit about. So if you print one of those out with the standard default print statements, you will get something that says that this is a list instead of saying it's an origin.
Yeah.
Or whatever.
Okay. And I guess that the act of defining a kind, right, an object with a capital first letter, is itself a program in the sense that it happens dynamically by executing that program, just like in Ruby, right?
Yes, absolutely. There are no keywords in Ioke at all.
Yeah.
So there is no definition happening. In fact, the only thing you do, you create a new object, you assign that to a name.
Right.
And as we talked about earlier, assignment is just a message sent to. So all those things, there is nothing really that you could say is defining.
Yeah. Okay, and the last question is in this space, I guess the fact that it's dynamically typed is mandatory, right? I mean, if you don't have classes, what would a compile time type checker do, right?
That's interesting, yeah, and it's something that I've actually been thinking about. That's definitely in the future, but I do have some ideas about how to make a statically typed version of Ioke. Not exactly like Ioke, but I have some ideas about how you can combine. First of all, obviously, as you say, if you can't have any static classes, you need to figure out another way. Yeah. So what you need is to do a fully type inferred engine for prototype-based object-oriented languages. Yeah. Once you have that, you can also start applying things. I'm not sure if you're familiar with structural typing.
I am, yes.
But I think that you can use the same kind of approach and talk about structural values.
Mm-hmm.
This is if I ever have 5 years, I'm going to take those 5 years off and do a PhD based on those things.
Yeah.
I'm not sure if it's ever going to happen, but I do think it's possible.
I mean, the idea of being able to add things at runtime to objects kind of flies in the face directly to static typing, because you would never be able to use it from statically typed code because it obviously doesn't know about it.
Sure. And obviously, the language that I would be doing would not be exactly like Ioke. It would be a kind of a dialect of it. But I haven't really gone that far in that thinking because Ioke is still not a year old from the first release. It's a very young language.
Yeah. And we'll talk about the status of Ioke and who uses it and stuff later. So the other thing, if we have objects and we can send messages to these objects, then we probably need to have something like methods that kind of are invoked if the message with a corresponding name is sent to the object, blah, blah, blah. So can you talk a little bit about methods?
Yes. So basically, you create a method by sending the message method with some code to it, and you get back something that is a default method. Now, these are objects too, and you can create them at runtime because everything is runtime in Ioke. You can create the macro facilities actually allow you to manipulate code in such a way that you can create your own implementation of methods that work differently if you want to, and so on.
Mm-hmm.
Yeah, I mean, methods are basically things that can be activated, which means that they have a protocol for how they handle being sent a message.
Mm-hmm. Okay. And they probably also define some kind of local scope.
Yes, they do have a local scope. That local scope actually happens to just be another Ioke object.
Mm-hmm. Okay.
So a local scope is actually an Ioke object. Because, so you don't have really local variables. You just have a local scope, an Ioke object that you have those variables on.
So it means there is another ground?
Yeah, well, so when you call a method, or when a method gets activated,
Mm-hmm.
the current lowercase ground is going to be the current context, which is going to be another Ioke object just.
Okay.
And that object obviously have also some neat stuff that makes possible to call methods on the enclosing object and so on, or the actual receiver of the method.
Mm-hmm. Okay. There are also macros, which people might know from Lisp, which is in Lisp is basically a way of defining syntactic forms that are then translated down to the usual list thing. So what are macros in Ioke?
Yeah, they're pretty different actually. Sometimes I think it was a mistake to call them macros, but that's, I mean, they're used for things that macros are generally used for. So let's step there. Just a very quick step back. There are actually more kinds of code in Ioke. So the first kind of code that you can work with is actually messages. You can work with raw messages, and messages is how you the message object is kind of the basis of the AST. That's the only node of the AST.
Yeah.
So you can work with these at runtime, create new ones, and modify them at runtime. You have methods that are default methods. You have also lexical blocks.
1 second. You said methods are. You mentioned default methods several times. I don't know what this means.
Oh,
methods?
sorry. So if you call them the method, you will get back something that mimics default method.
Okay, I see. Mm-hmm.
It's just the kind of all the methods in Ioke, because
so that means you could write another method which has a different name, let's say blah method, which creates something that mimics another method object and therefore behaves somewhat differently.
Yes, absolutely. As a typical example, the way I do interaction with Java, for example, doesn't actually use default method. Instead, it uses something called native method.
Yeah.
To invoke Java methods.
Okay. It reminds me a little bit of the meta object protocol stuff, where you can change the nature of the things from which your program is built.
Yes, definitely. I definitely have gotten lots of ideas from that point too.
Okay.
Ioke is a large mix of everything I've ever read. I try to distill in some ways. Anyway, there are two kinds of macros actually. So the first one is what you get if you call macro. The second one I call syntactic macros. The difference is that macros are actually executed at runtime. They will always be executed. The difference is that they take their arguments as code, and they can change them and do stuff with them.
Okay, so it also means that the arguments are not evaluated upon call.
Exactly. They can be evaluated when the macro feels like doing it, or however the macro feels like doing it after doing some stuff with them. But they don't have to be evaluated at all, which means that you can, in most cases, in cases like where in Ruby you would probably use a block, Ioke actually uses macros. So, for example, most of the enumerable methods are implemented using macros instead of using something else. I don't use lexical blocks specifically at those points because it turns out to become noisy to have to create lexical blocks all over the place.
Okay. So can you give an example of where a macro can, of what you would use a macro for? Like you said, the enumerable already, but maybe a simple hello world kind of macro where it's important to understand that the arguments are not immediately evaluated?
Yeah, that's slightly trickier because the whole point about macros is that they allow you to do abstraction on code.
Right.
And abstraction on code is tricky to explain in a hello world object concept. Well, I mean, obviously, actually, there is a fairly simple one you could actually do. Take if.
Yes, they actually had that in mind.
Yeah. If is a typical example because you really don't want to evaluate both the then or the else branches until you know what the result of the first argument is going to be.
Yeah.
So first of all, you'll have to evaluate the first argument to if, and then based on what value that is, you evaluate either the second one or the third one of the arguments, but not both of them.
Right. So that's also, I think, the canonical example for macros in
exactly.
Lisp.
Yeah, I should have come up with that earlier.
You said that there are also, so I'm not sure if you meant that when you said syntactic macros, there is the kind of a way of defining syntax in Ioke.
Yeah, that's also an unfortunate naming that I probably should have gone away from. The difference between a syntax macro and a regular macro in Ioke is actually that and this is, I should probably have called them semantic macros, but I'm not sure if that would have made sense. The syntactic macros work the first time they're called at a specific place. The first time a message is sent to a syntax macro, they are expected to return new code. And that code will be replacing the message sent to the syntax macro at that place in the AST.
Right.
That's more like the Common Lisp version of expanding a macro and inserting that at place.
So, but it means that, so Ioke doesn't have keywords, obviously.
No.
If I wanted to introduce keywords or something that acts as keywords in, let's say, an internal DSL, right? I mean, keywords in that sense are just constants or something, or symbols or whatever. How would I go about that using the macro facility?
Well, I would probably... One of those things with the AST that comes as a surprise to some people is that you actually can... say that I call a macro... If I call a macro the first thing I do in a file, if I say foo, that thing is a macro. That macro can actually walk the whole AST for that file if it wants to. And it can find all those keywords and do something with them. That's one way of doing it. Another way of doing it, but the important thing to remember about these macros is that they're still scoped the same way as everything else.
Okay.
So they're looked up, they're objects in themselves, these macros, and they are looked up the same way as methods. So you still, if you want to have something that works the same no matter what, you'll have to find a way of, not having it evaluated in the same namespace requirements as the rest of Ioke. And the best and the easiest way of doing that is to have a top-level macro invocation that actually changes the AST for everything beneath it. But that's kind of tricky. The other thing that I've been thinking about doing, because I actually quite recently rewrote my parser from scratch. I actually went away from Antler. I got some really good benefits from doing that. Antler was not really right for the kind of requirements that I had for Ioke. But as it turns out, it's now going to be pretty simple for me if I want to add an extensible parser. So you can add kind of, I talked to Slava Pestov about this, for example, adding kind of parsing words or reader macros if you come from a Lisp background. Yeah,
I mean, that's, I think you might have heard about Converge, where you can define grammars inside of the language and then parse the grammar and automatically, well, not automatically, but as part of the compilation process, translate them to an AST of the base language of Converge. And reader macros are something along those ways. You can just feed in any kind of text, and the responsibility of the reader macro would be to create an AST from it. Yeah. The difference is I'm not sure if it's possible that that's how I'm going to do reader macros, but I also might make reader macros something runtime. Okay. I'm not sure. I haven't decided yet. I haven't added it. It might come, but I have other things that I want to do first. So we'll see what happens. Yeah. Introspection and reflection. I guess if you do everything at runtime and everything is cells and everything is objects, then introspection and reflection you get kind of for free, right? Yeah. Everything is mutable. Everything is runtime. If you have an object that you're really unsure of, if say for example, one of the things, most of the reflective facilities are actually
methods on the object itself. So you can ask out an object for what cells it has and stuff like that. But as it turns out, those things, if you create a really weird object that doesn't really have any parents, say for example in Ruby you have this concept about blank slates. A blank slate is an object that doesn't really define anything and undefines all the methods, so you can do it to use it for the builder pattern, for example. If you have one of those blank slates in Ioke, they're really even more blank than they are in Ruby. And they're really easy to create because the only thing you need to do is create a new object and just remove all these mimics. And then you suddenly have a blank slate.
Yeah. And that's basically, you basically get the collection of mimics and set them to null.
Yeah, that's not exactly what you do. It's the collection of mimics are more like a list that you just clear it.
Okay, good. Yeah, well...
But anyway, if you do that, that object is not going to respond to all of the regular questions about what it mimics or what cells it has and stuff like that, because it doesn't have those methods anymore. So I have this specific object called a reflector, and the reflector can be used to introspect on other objects. So you can basically say, okay, reflector other cells, and send it an object, and you get back those cells, even if that object is a blank slate.
So it can kind of simulate those objects having methods.
Yes, almost, but not all methods. Just the methods needed for reflection and introspection. Okay. So in the core code where I really need to be able to handle everything, I use the reflector to make sure that if I have weird objects like that, I can handle them too.
Another nice thing that I saw when I read the I wouldn't call it maybe specification tutorial kind of thing. Is aspects.
Yeah. So the aspect facility is not really that weird. It's actually implemented in Ioke itself, and it's pretty basic.
Yeah.
It's actually just based around the fact that I can wrap code around other code and do that pretty much automatically without any...
It's more like Lisp's before and after methods.
Yes, exactly. It's very limited compared to some of the cooler aspect systems.
Although I would argue that, I'm not a very big fan of AO on code level. I think it's a good concept for designing systems, thinking in terms of viewpoints and aspects and stuff. But I think it's probably enough if you have it on method level and you don't probably want to, advise the third if statement in the method body and do
yeah, exactly.
Like that.
That's the whole idea behind how I did it, because I think that Ioke is powerful enough as it is without... I don't think that as full-blown aspects would actually add any interesting power to Ioke.
Yeah. So, actually, when I was first looking at Ioke, I was actually somewhat surprised that it's not a functional language, that there is assignment. That's kind of not in line with the current hype.
Yeah, I know. I'm a revolutionary. No, I to be honest, I don't really. The whole functional hype right now. I do kind of agree with it, but it does annoy me too from a language perspective. It's like, okay, sure, we've had functional languages for 50 years. Now suddenly everyone is doing them, and it's really, really cool, and everyone is thinking about the concurrency problem.
Yeah.
I don't find the concurrency problem very interesting, so I wanted to explore something very different. So I didn't really feel the need to make Ioke functional. I do think there's definitely value or power in being able to do mutable stuff, and the kind of rampant mutability that Ioke have is actually quite nice to be able to do. So yeah, Ioke doesn't solve the concurrency problem at all.
So you don't have a specific concurrency story for it at all? So
Not at all, right? Actually, I have a few ideas. Yeah. The one thing that I'm going to add sooner or later is going to be transparent futures.
Okay.
I'm also thinking about doing something like adding some of Closure's concurrency primitives without even having the requirement of stuff being immutable.
Yeah.
I think that it's possible in language if you just trust your developers to do the right thing. And Ioke is definitely powerful enough that you need to be able to trust the people doing it.
Absolutely.
So in that case, immutability doesn't necessarily buy you that much. You can actually have an STM, and if people are just responsible adults when they're programming, they can use that STM for kind of talking to each other over threads, but they still get the benefits of mutability all over the place. And I'm not sure how that's going to work out. I'm going to add it at some point, but it's definitely an idea.
Okay.
That goes in line with the rest of Ioke.
STM stands for Software Transactional Memory, and a long time ago we've had this episode on SE Radio with, I think, Dan Grossman, where we discussed STM and the garbage collection.
So should we define transparent future too?
Yeah, why not?
So basically a future is an object that you say, okay, sometime in the future, I want the result of evaluating this function. That result can be, that evaluation can start being done in another thread, but you don't do any explicit thread creation or anything like that. Mm-hmm. And saying that it's transparent means that when the object is done being created, or the value is done being created, it just replaces the place where the future was stored.
Okay, so it's not that you explicitly call, is value available, blah, blah, but you kind of magically pop it in.
Exactly. So in Scheme, you have, for example, I think it's called delay and force. So you can say delay and then some code. And then when you say force, you will actually get the real value. But you always have to say force when you have one of those things. Mm-hmm. In Ioke, I will be able to just let the real value actually replace the future object.
Mm-hmm. Another thing that I saw about assignment is the statement that Ioke also supports assignment of places.
Yes.
What's that?
So a place is kind of like Common Lisp setf.
That probably won't help much for most of our listeners.
Sorry. Well, the whole idea is that assignment to a name can be interesting, sure. But if you allow assignment to a place, that means that you can model assignment the same way no matter what. So, for example, if you look at the, say for example, sometimes you really want to assign a cell that you can't really express as a message name. So the whole thing of doing x equals 1 doesn't really work if x is a message that, say for example, you want to assign the empty message.
Yeah.
You can't really say equals 1. That doesn't really work. So you need a way to be able to assign these kind of things. And the way Ioke allows you to work with cells that you have to name, the way you do reflection is by calling cell and then giving it a name what you want to. But you can also say cell x, and then after the parenthesis equal 1 to assign to that place.
So in other words, could I try to explain it in a way that says that the L value of an expression can itself be something that's computed?
Yes, exactly. It can have arguments.
Okay.
So that's how it's a general feature that makes it possible to do, for example, list assignment using square parentheses. But it's a general thing, and you can define your own places like that.
Okay, now I get it. Okay, I guess the last feature that I want to get at before we kind of look at the state and where it's going and where people can get information about Ioke is Comprehensions. I know it's not unique to Ioke, but we haven't talked about this concept in general in SE Radio before very much. So what's a comprehension? It's also known as list comprehension, right?
Yeah, so comprehensions, they're pretty funny because they're not really interesting in Ioke. I made them. I just implemented them just for fun. They were the first real thing I used my syntax macros to do.
Right.
Because as it turns out, a comprehension is actually just a piece of syntax that can be transformed into applications of map and flat map and filter. Mm-hmm. So the idea of comprehensions, if you have a math background, you kind of really like this concept because you can declaratively say that, okay, take X from this collection of values and Y from this collection of values, multiply them and then filter them out if they are larger than this and then return this result. So it's a way of declaratively kind of creating collections of values or lists of values.
In some sense, it's a glorified for statement, right?
Yes.
Where you can iterate over several things at the same time and then use or do something with the values from all these iterations.
Yeah. But the difference is that you're actually working with syntax here. So the syntax is on top of these operation, so you don't see all the calls. If you actually look at the expansion of a typical call in Ioke, it's pretty hard to follow the combinations of map and flat map and stuff like that. Most interesting comprehensions are actually combinations of iteration, nested iterations between two or more collections, which turns out to be coming quite annoying after a while to follow.
Okay, so I guess that concludes our discussion about the various features. Let's kind of zoom out and take a look at the somewhat bigger picture again. So have you done any actual kind of project work or any actual real work as opposed to experiments with Ioke? Any experience, or are other people doing that, or what's the state there?
No, so far it's mostly been experimenting. I mean, I'm working with examples of different kinds. Quite a lot of Ioke's core library is actually implemented in Ioke itself, so that drives some of the evolution of the language. I have at least one colleague who's looking at using it to as a code generating DSL, because you can do internal DSLs really easily in Ioke. So he was thinking about doing something that actually generates code. As it turns out, Ioke is really slow, so you don't really want to run it at runtime.
Okay. It's based on the JVM, right?
Well, actually, I mean, it was first created on top of the JVM, but I also have a CLR port right now.
And the way it works is not by generating bytecode, but you basically just implemented an interpreter in Java, kind of.
Yes. It's because you can change the AST at runtime, it turns out to be pretty tricky to create a compiler for it.
Yes, exactly.
I do know how to do it. It's just a small matter of engineering.
Okay, that's what the nuclear fusion guys also say.
Absolutely.
Years.
No, I mean, what I need to do is basically have a good way of compiling small pieces of bytecode and then have an invalidation scheme of some kind. So I can just throw the bytecode away if it becomes invalidated. So it's going to be, I am going to have a just-in-time compiler of some kind, but it's also not that interesting because having it be fast is not really interesting from an expressivity standpoint.
Yeah. So, where do you go from here? I mean, I read something about Ioke S and Ioke and then some other letter.
Yeah, so the first version of Ioke was Ioke 0. The second one was Ioke S.
Yeah.
The current one is called Ioke E. The second one is going to be P, and I'm probably thinking about releasing P pretty soon. It depends on, I have a few things that I really want to add to it before I do that. The first one is something I call tree rewriting, where right now the way you work with the messages, the ASTs, is pretty much imperative. But I want to make a more declarative approach about how to rewrite message chains and ASTs. So I'm working on that one, and then I'm not sure if that's going to be in P or not, but I want to have an intermediate language. Basically, I want to have a DSL in Ioke for the implementation of Ioke, because I'm getting fed up with having to work with both the Java and the C# code.
Yeah. Okay. So these 0, E, and P things are basically fancy version numbers and not different kinds of Ioke.
Well, it's a little bit of both, actually, because as it turns out, my implementations called IKC is the CLR version, IKJ is the Java version. They have real version numbers.
Okay.
But the letters kind of thing, it is more of a versioning of the language. I try to be consistent that when I actually change the real language, I make a new. So they're kind of milestones in the evolution of the language. I can make new releases of the runtimes without actually changing that letter.
I understand. Yeah. Okay. So where can people find more information about it if they're interested?
So ioke.org have all the information necessary. You can get links to the mailing list there. There is also an IRC channel. It's pretty quiet right now, but it goes through periods when people are talking quite a lot there. Those are really the main. I mean, the mailing list. Obviously, if you want to find out information about Ioke, ioke.org is the first place to start. But if you have questions, the IRC channel or the mailing list are definitely the best place.
Okay. Any conferences where you're going to talk about it in the near future?
Yes, that's a good point. I'm actually going to be talking at it in Malmö at Öredev in the beginning of November.
Okay, I'm not sure whether we're going to publish this episode before that, but let's hope. Probably not, actually.
Yeah, after that, I don't know if I have anything lined up. I've done several talks about Ioke this fall, and there should be actually a talk coming up from the JVM Language Summit about Ioke.
Okay.
There's also, if you search for Java soon and Ioke, I did an hour-long talk there where I showed some code and stuff like that.
Okay. Good. I guess that finishes the Ioke discussion. I would, if you have 2 more minutes, I'd like to take the chance and ask your opinion about the general state of languages, maybe especially on the JVM. We have all this stuff coming out, Scala, Clojure, Erlang. Well, it's not JVM, but it's also, it has been, well, I'm not sure if it's still hype or whether it has been a hype. And you have all these things like Boo and F# and all that stuff on the CLR. Axum.
Yeah, I think that the current state of languages is definitely encouraging. I am happy to see that there's finally. We've been spending almost 15 years in a very boring language climate.
Yeah.
I was never happy with the idea that Java is the real big language and you can use Java for everything. Java definitely has its place, but it's. The whole idea that one language is good enough for everything is just, I don't think that's true. So I'm very happy to see that people are finally starting to focus on languages. In my opinion, the language is actually your most important tool.
Yeah.
And choosing the right tool for the job is definitely what being a programmer is about. So I think it's great to see all these different approaches being tried and all these different languages that are focused on different things coming out.
Yeah. Any opinion on which one of those will last? Will have lasting,
Oh, I hope most of them will last. Actually, I mean, several of them have reached the size now where they will be. I mean, they might not be big, but they will definitely last.
Yeah.
I'm personally very happy about Clojure.
I'm not surprised.
I like Clojure. Scala definitely has some interesting ideas too, but of all the JVM languages, Clojure is definitely my favorite of the ones that I'm not biased towards, of course.
Yeah. Something I find very interesting is that the distinction of language and runtime platform like JVM and CLR is becoming more important. So you can have many languages on the same VM, therefore giving you some kind of basic interoperability.
Yeah, and I think this is the good thing about JVM right now. Sun has definitely realized that they can get more leverage out of the JVM as a platform.
It has taken a long time, but I think they're finally there.
Exactly. Yeah, I'm part of the JSR 292 expert group that aims to add some features to the JVM that definitely will not help the Java language, but is actually suited to help the other languages.
Yeah. Is tail recursion going to be in there at some point?
We're looking at it. It's not going to be in Java 7,
okay.
But we're definitely looking at it. And there is a proof of concept and an implementation for the DaVinci machine.
Okay.
So there is definitely a possibility that we get tail recursion in Java 8.
Okay, good. So, anything else from your side you want to add? Any words of wisdom? Any closing remarks?
I don't have any words of wisdom.
Okay.
Thank you very much.
Thank you for being on the show. Bye.
Bye-bye.
Thanks for listening to Software Engineering Radio. Software Engineering Radio is an educational program brought to you by Hillside Europe. If you want more information about the podcast and all the other episodes, visit our website at se-radio.net. If you want to support us, you can donate to the SE Radio team via the website, or you can advertise for SE Radio, for example, by clicking on the Dig Reddit Delicious links and the /dot button. To contact the team, please send email to team@se-radio.net, or if it is specific to an episode, please use the comments facility on the website so other people can react to your comments. This episode of SE Radio, as well as all other episodes, are licensed under the Creative Commons 2.5 license. Please see the website for details. Thanks to Charlie Crow and the Podsive Music Network for the music used in this show. The song is called Vegas Hard Rock Shuffle.